Hello there. In this video, I want to talk about arithmetic sequences, and this builds off of the idea of sequences that I released in a previous short. Now, a sequence is a list of terms defined to be a discrete variable, where the terms that exist within a sequence belong to a pattern, but any terms in between do not belong to that sequence. So for example, in this first one, 1 belongs to my sequence, so does 4, 7, 10, 13. So does any additional number that fits this pattern. But 2 is not an element of this set because it does not fit the pattern. We can't add or subtract or whatever the pattern may be in this case to get 2 at any point. So 2 would not be an element. This is why it's a discrete variable. We're counting off terms rather than measuring along a line to see what numbers can we get and can't we get via domain and range. Okay, now what is an arithmetic sequence? An arithmetic sequence is a sequence with a common difference between each term. That means the difference between consecutive terms is always the same. And we see that with the 2 examples I've written on the board. I got 1 to 4, that's a +3 difference. And we got another +3, +3, +3. And the beautiful thing about the ... is it indicates to us that the pattern keeps going. So we can assume, yes, this is an arithmetic sequence. This other one, we have a -4 difference. So when we say difference, we're referring to a number that we add or subtract that's the same every single time. An example of a non-arithmetic sequence might be Fibonacci's sequence. Now, the pattern there is consistent in that we add the 2 previous terms. Say 1, 1, we get 2, and then 1 plus 2 is 3, 2 plus 3 is 5, and so forth and so on. But the difference between consecutive terms is not the same each time, so this would not qualify as an arithmetic sequence. Now, arithmetic sequences fit into this pattern of linear behavior because the addition of the same number each time can help us get a slope of sorts. It wouldn't be referred to as slope because that would refer to linear functions only. So let's talk about the formula of an arithmetic sequence. And it's going to be noticeably similar to what the slope-intercept form of a linear equation is. So the formula is a sub n equals a sub 1 plus the quantity n minus 1 times d. So d is our common difference. Our common difference. A sub 1 stands for our first term, and a sub n stands for our nth term. Basically, any term we want to find within the sequence, and that n directly correlates to this n. If we wanted to say find the 10th term, we would go ahead and plug in 10. So what would this formula look like for this first example? Well, our first term, a sub 1, is 1. Our common difference we identified to be 3, so d equals 3. So I will go ahead and put in a sub n equals 1 plus the quantity n minus 1 times 3. Now, to really quickly show you the similarities between this and slope-intercept form, I'm going to go ahead and distribute the 3. So I get a sub n equals 1 plus 3n minus 3, and then I got 1 minus 3 is -2. So a sub n equals 3n minus 2. This is very similar to if I had said y equals 3x minus 2. We can see the common difference there. Now, the main difference, sorry, we can see the similarity, not the difference. The main difference I wanted to talk about is notice how we start when n is equal to 1. So if I were to plug in 1 here, I'd get a sub 1 equals 1 plus quantity 1 minus 1 times 3. Well, this would give me 0, which will cancel this out, and I get a sub 1 equals 1. Whereas with a slope-intercept equation, I start when x is equal to 0. So the big question is, why is there this difference? Well, the x being equal to 0 is because we want to start with our y-intercept. Whereas with a sequence, it doesn't really make sense to start with a 0th term. So we refer to this as the first term, and we subtract 1 from our variable in order to compensate for this difference in the formula. So let's go ahead and look at, and I'll clean a little bit of this up, let's go ahead and look at the formula for our other sequence. A sub 1 would equal our -5 here. D we identified to be -4. And there's a couple ways we can write this. So using the formula in its rudimentary sense, I'll say -5 plus the quantity n minus 1 times -4. Now, if you wanted to write this differently, you could take this negative and replace it as a minus sign for the plus. So a sub n equals -5 minus n minus 1 times 4. I do prefer that because it looks nicer, but at the same time, I might then forget accidentally that the difference is a subtraction of -4, or a subtraction of 4 rather than the common difference being +4, which indicates adding. So, but that's just a personal preference for me. So the purposes of these formulas is to be able to allow us to predict any number in the pattern, much the same way we can do that with a slope-intercept form linear equation. So let's talk about a sub n equals 1 plus n minus 1 times 3. Say I wanted the 100th term in the sequence. So that I would write that out as a sub 100 equals 1 plus, and I would put the 100 in for n, times 3. I get a sub 100 equals 1 plus, so I get 99 here, times 3, and then I just have to make sure I obey my order of operations. 99 times 3, well, that would be 300 minus 3 would be 297, so 1 plus 297 is 298. I wouldn't have to follow the pattern of 1, 4, 7, so forth and so on to get to the 100th term. Let's go ahead and take it up a notch. Let's use a sub n equals -5 minus n minus 1 times 4, and let's solve for the 567th term. Let's make it tricky on us. So 567 goes in for n. So 500 times 4 is 2,000. 60 times 4 is 240. And 7 times 4 is 28. So we get 2,268. But then minus 4 is 2,264. So this equals -5 minus 2,264. That gives us -2,269. So those are all the basics that you need to know for arithmetic sequences. If you liked this video, go ahead, give it a thumbs up, and subscribe to the channel. If you would like to see more videos like this in the future, leave a comment in the comment section, and I will see you for the next one. Thanks for watching.